Dear students, welcome to CR's digital classes. Today let us discuss the concept of sign test. So sign test is one of the simplest non-parametric test that can be used as an alternative to one sample t-test. So sign test is the easiest one. So actually non-parametric test, all the tests are easiest to handle and calculation will be a bit easier. So in that again sign test is easier and we can utilize it as an alternative for one sample t-test also. So now let us check it out how it goes on. This test is performed on pair of observations depending on their sign magnitude. So sign test particularly is useful when the data will be given in terms of symbols like presence, plus symbol, absence, minus symbol, like that. We have the data in symbols. So whenever such type of data we have, we'll go for sign test, and in pairs we'll get that the observations also. So in such situations we'll go for sign test irrespective of the numeric magnitude, means numbers are not required. If symbols are there, still we can go for sign test. So now let us check it out. What is the procedure for to obtain our sign test? So procedure, sign test for single sample, let us discuss in this session. So if xi is equal to 1 to so on up to n represents a random sample of population. So I am considering some random sample xi ranges from 1 to n. Next f of x is equal to represents a distribution function of a random sample xi. So I am considering some distribution function also as f of x. Next 1 m mu and 2 m mu represents the specified value of fx, means here median will consider, and mu as a notation for moments we are considering here. 1 and 2 values for fx we are considering. Now let us check it out. Then based on this, the test hypothesis is sign test is given as follows. Again we'll frame null and hypothesis for every test. So for sign test also let us frame based on the assumption whatever we have considered just now. So null hypothesis will be h naught 1 m mu is equal to 2 m mu. Whatever just now we have considered out of our distribution, we considered these two the same thing, we are considering it as equal. So the first median whatever we are considering, that goes to the equal to second one. So or one more assumption we can make, h naught for h naught, h probability of x greater than 1 is equal to probability of x less than 2, which is 0.5, because equal chances are there, we are specifying here. We know probability always will consider whenever equal chances will give, will consider it as 1 by 2, that is 0.5. The same thing I am considering here, means I am giving equal importance, both are equal, I am specifying here. So that is your null hypothesis. Now let us frame alternative hypothesis also. Alternative hypothesis h1 will be either, three cases will get. So either first one is not equal to 2 and the second one, so for first one equal to we have considered, so obviously not equal to one of the cases could be. Now second one x greater than 1, same whatever we have considered in null hypothesis, the same thing with a not equal to symbol, so not equal to 0.5. So alternate we know it's opposite to null hypothesis, so their equal to we considered here, we have to specify it as not equal to. The same thing I have considered here. Now next, what are they? Let us check it out. Since median 1 mu of population is drawn from a randomly selected sample, the average of it will be divided and the sample observations into two halves. That's what we have considered equal them, equal importance, half and half. So 0.5 we have considered, that's what they are specifying here. The samples average we are considering because we have selected that a random sample they are specifying here, where one half contains sample observations below 1 mu and the other half contains sample observations above 2 mu. So first half will be above and the second half will be below, they are specifying here. So in problem we can understand clearly because it's just a procedure. So out of assumptions we are making the conversations here. So when you have problem we can understand how it goes on, how median has been dragged, and how the values will divide into two halves. So that's what they specified accordingly with some symbols and all. So that is your how the data is divided we specified here. Then let us check it out. After getting the values, how the test statistics will go on. So the test statistic that must be applied on sign test is as follows. Take the difference between xi minus 1 mu, where I is equal to 1 to n. So differences we are considering here, and then check whether xi is less than 1 mu or not. So we have to check it out whether that is less than value or not. If the result is true, assign negative sign to the difference, else assign positive sign. So based on the data, after subtracting, we'll get the symbols, right? In first step, we have subtracted the values. From the first set, we have subtracted median values. So if it is less than, we'll assign minus sign. If it is more than, we'll assign plus sign. So because in the beginning I said whenever symbols we have, we'll go for sign test. Now I have got my plus and minus signs. Now we can go for the further procedure. So first we'll specify the symbols by taking the differences based on the median. Then if x denotes the total number of positive terms, x minus m denotes the total number of negative terms, then for a large sample of test statistics given by. So here one more condition we are specifying, like whenever non-parametric test we have, based on the sample size, we'll go for the regular sign test formula or run test formula, like that formula will be. And if sample sizes are higher, then approximately we'll go for normal distribution. So whenever signs are here, x denotes the symbols, right? So that symbols, if it is positive and negative terms we are getting for large samples. If sample size is more, so then we'll go for normal population. So normal population formula also let us have a glance here. So this becomes a z is equal to x minus np by root over np cube, becomes a normal population formula for us. So standard normal formula itself we are considering, and in that we are substituting mean and variances, that is a binomial, because it is like a success and failure cases. Positive if it is greater, negative if it is lesser, like that success and failure options we are getting here. So approximately it goes to normal population, where mean and variances we are substituting of binomial populations. So for positive sign, this becomes a formula for us. So what are they? Have we got that PQ? Let us discuss that also. So the above equation is called as standard normal variate, where P is equal to 1 by 2 and Q is equal to 1 minus P we are considering. So I just now I said it is in terms of like absence and presence, like success and failure. So we are going to handle this Z formula as normal variate formula, where P is equal to 1 by 2 and Q is equal to 1 by 2. Equal chances will be 0.5 we have specified, right? So P is equal to 1 by 2 and Q is equal to 1 by 2 you will get. So the above equation can be written as, now the if you substitute that 1 by 2, 1 by 2, how the normal distribution formula will get, that also let us check it out now. So Z is equal to x minus np by root over np cube is a formula just now we have learned. So substitute in that, we'll get x minus n into 1 by 2 divided by root over n into p value 1 by 2, q value 1 by 2. I have substituted. So finally our formula will be x minus n by 2 by root over n by 4, which will be using for sign test whenever samples will be larger. So larger samples, this becomes a formula for us. Z is equal to normal distribution formula, x minus n by 2 by root over n by 4 becomes a formula for us. So this is your Z formula, and the conclusions decision will be same. How we'll take for general large sample test, the same decision. So if calculated value is less than tabulated, we'll accept a H naught, otherwise we reject H naught. So the same conclusions will go on here also. So this is your sign test for one sample. Hope you have understood this sign test. See you all in the next session. Thank you.